What you're looking at is a duplexer for a repeater consisting of 4 cavity filters. It's got 2 cavity filters for the receiver and 2 cavity filters for the transmitter. I have one of the transmitter cavities open just to show you what it is. It's really nothing but a cavity, and it's got a hollow tube with another tube that slides in and out by just in turning this knob. These small wires here hooked to the bottom of the PL259s are called loops, and they're what couple the input and output of the cavity filters together. Put the cover back on here. Put this cavity back into position where it normally is. Okay, I've got an illustration here of a similar type cavity filter. You see the knob here where you adjust the cavity, input and outlet, and these are called coupling loops, the little wire pieces that I showed you inside the cavity. And then you got the adjustable rod here. The basically a cavity, it's a cavity filter. It's a resonant filter. It has capacitance and it has inductance. By turning this knob, you slide the rod up and down. That changes the inductance, but also by the proximity of the bottom of the rod, it can change the capacitance. What I've done here is I've hooked this up for checking the transmit capacity cavities to make sure they're on the frequency I'm looking for. In this setup, I'm using Scott Gray's repeater frequencies. So the way this is set up, on receive cavities, I have a 50 ohm dummy load, and that's because of the interactance of the transmit and receive cavities. You have to have them loaded up, connected, because they interact and will affect your readings. This is the position where the antenna is normally connected. I have this connected to my Motorola R2660 communications analyzer, and it has a tracking generator function. So this goes into the scope. This connection here on the inlet of the first cavity goes into the tracking generator also, but it has an RF generator. So that RF generator sends a signal into the cavities, and then the scope displays what the signal coming out looks like. Well, if you look on this, it shows the center frequency is 447.475, which is the peak there on the center. And if I turn the knobs, well, I'll show you what the cavities do by turning the knobs. As soon as I get this knob back on, well, that one's not going on. Anyway, I'll turn this one knob, and you can see that the peak and the center frequency is changing. So what I've done ahead of time is adjusted these for the peak and minimum. The higher that peak, the minimum dB loss or attenuation at that point where the transmit frequency is. And if you look at this point right where my finger is, that's the receive frequency. That's called a notch, and the notch is adjusted by these 2 knurled knobs on each of the cavity. By sliding, one's fixed and it can be moved to another point, the other is movable by sliding it back and forth. You can fine-tune that notch, and where you want to set that notch is at the receive frequency, which is 442.475, which is a typical 5 megahertz shift between transmit and receive. So anyway, the reason that's set like that is because when you're well, let me back up. I should have explained it first what a duplexer is used for, and why you need all these cavity filters. Duplexer for a repeater, what a repeater does is when you're talking on your radio, the repeater hears your signal through an antenna, and then it relays that same, your voice, back out that same antenna. You only use one antenna. So how do you do that? Well, you use this set of cavity filters to keep the transmit at one frequency and the receive at one frequency. That's why it's also called, it's called a duplexer, because you're using two signals at the same time. So you want this, you can't read it on this scale, but if I go to another scale, it would show about 80 dBs of attenuation at the receive frequency. So while you're transmitting, no attenuation, but the receive is just about completely attenuated. Got another chart here to show you. On this chart, you can see the blue line. Here's the transmit frequency, here's the receive frequency, attenuated. Well, the other two cavities are the red line. So you see while you're receiving 5 megahertz below the transmit, you've got this practically no attenuation, but you have down here for the transmitter, you're totally attenuating the transmitter. Therefore, you're able to duplex or receive and transmit on the same antenna at the same time. So anyway, that's this is basically how you tune a duplexer and what it does. Thank you for your time.